through a few things. So good evening. We're here for the Math 130 6 to 8 shift class. And I have a few little updates. So I decided I'm just going to make videos of all the lessons. I still would love people to come on the live session. So, you know, still come and work if you'd like, or come and ask questions about the worksheets. But I'm making like videos of all of the problems that I have on your Google Doc that we're going to do for each lesson. I went and I'm going to make videos for. So I skipped 1.1, but I made the 1.2 today and the 1.3, and I already have the link in JetNet. It's pretty awesome. And then I'll make 1.4 and probably 1.5 this weekend. I'm going to try to get a little bit ahead for those that are completely online students that, you know, want to keep working ahead. So I might skip a problem here and there, but for the most part, it's me working through the problem so that those folks at home, and if you're on the live session, you don't quite get through everything for the night, you can go back and rewatch those and at least make sure and check your answers for those students that are at home working and just want to hey, I just want to kind of check in my answers and see if she's getting the same things. So I'm going to share my screen so that everybody can see the scoop of what's going on. Wait, are you seeing my JetNet screen or are you seeing my spreadsheet?
Yes.
I'm seeing the JetNet screen.
Okay, good. So here we are. And you'll see here it says YouTube videos for each lesson. And then today I changed it to say by Sarah. So you know it's me, because it used to, if you clicked on it before, it said it was Eric. So if you click on this, it'll take you to my YouTube page. And there's lesson 2, 1, 2, and there's lesson 1, 3. One's 18 minutes, one's 24 minutes. So this is going to be especially helpful, I think, for those students that are not able to be in the live sessions. And if you just want to check your work, you can just go to that and kind of fast forward through and just make sure your answers all kind of match my answers. And if they don't, let me know, because I'm kind of doing it on the fly. So I need to know if I'm making a mistake. It should be all good because I kind of have my answer key from before they did an update to the workbook. So it should be fine, but just in case. Also, everybody should have their 2 packages by now. You should have received your package with the worksheets and exam reviews. And remember, I mentioned last week, the ones at the top that say MAT 040 worksheets, throw those out. There's a section that says MAT 040 quizzes, throw those out. Use them for scrap paper. There should be blank on the other side. I put those in my printer. They're great. It's great paper to use for printing. You've already paid for it. Only keep the MAT 130 worksheets. Those are the ones that you're going to be scanning in. And when you go to scan those in, do not send those through Alex. I've had some people trying to send me worksheets through Alex. You want to click on right here, this blue button with the down arrow. You're going to click on that, and then it's going to say, where am I going to find your worksheet? So wherever you saved your uploaded scan document, you're going to find that, and you're going to attach it, and there it will go. And I've been busy trying to make those videos today and getting caught up. So I will get caught up on my grading this weekend, the 1.1 worksheet, 1.2, and then tonight, hopefully everybody's uploading 1.3. If you're a day or so behind on the 1.3, it's not the end of the world because I haven't gotten to those yet anyway. I do try to stay up on those though. Project Unit 1 is right here. Now, I know some of you were clicking on that and it was only bringing up the Microsoft Word description of the Unit 1 project, but I had other documents there, so I don't know. So what I did was I made links. So click here is the random districts. You'll know once you read through the project what that means. Click here is the population data. Again, you'll know once you read through the project. And then click here is a student example of somebody that I did from last fall. So you can kind of see what the expectations are. So that's your Unit 1 project. Next week, we're going to be working on lesson 1.5 and 1.6. And then remember that the week of the 21st, I'm going to be out of town. So there's not going to be a live session on either of these days. But because I'm making the lessons ahead, I will have lesson 1.7 ahead next week done. So anybody that wants to work on that and come and ask me questions or meet with me or meet with Megan, the amazing tutor. I think Darla already has time scheduled, or Teresa, or both of you. I know a couple of you have mentioned you've already scheduled some tutoring times with Megan. You can meet with her and ask questions over 1.7. And so I'm allowing those 2 days to finish 1.7, get your worksheets in, finish up your project. That's kind of a free week of work time for you all. And then when we come back on Tuesday, the 9/28, that's when I'm gonna have, your project is actually due on Thursday, the 9/30, because I wanted to leave like Tuesday, kind of like as a day where people can reach out to me. And if you need to meet with me on the Zoom in between my classes on that day, we can do that, answer questions so people can tidy up their project. Does that sound good with everybody that's on the live session? Does that all make sense for everyone so far? Okay.
I do have a question.
Sure.
For the project, I tried to go in and just print the directions down, so I had them right in front of me. It wouldn't print. It wouldn't print. Mine wouldn't print. It said something with the margins and it wouldn't print. So I don't know if it's just my computer. Has anyone else tried to do that yet?
So email me, Teresa, and then I can save it as a PDF and
Okay.
email it back to you as a PDF, and that might print better.
Oh, okay. All right.
Send me an email.
Okay.
I have adult ADD, I'll forget, so don't rely on the conversations. Just make sure you send me an email. I need documentation to remind me to do things. I could write it down, but I've got too many spiral notebooks. You guys should see. I got really super organized. I got all these like spiral notebooks, and it was like super exciting to look at all my tabs. But then I'm like, so where did I write that? Like, which tab did I put that? Oh gosh. So I'm just like not worrying about that today. I'm gonna have fun with you all tonight. So we are going to work on 1-4. Here is the plan for today. Most everybody got through this today, page 71. Did we get through that this morning? Let me look at 71. No, we didn't. We got through page 66, 1 through 10. So that's where I put page 71 is if you have time, if you want to work on those. And I'll try to make sure that I kind of cover those in my, when I do my video for 1-4, so that if people want to go and do those extension problems, you've got them. Okay. So how about we turn to, I'm going to let you guys go. Actually, I'm just going to let you guys work right here. Do you guys mind working while I'm here? Do you want to be in a breakout room where I can't hear you unless you need me? Does anybody care?
Doesn't matter to me. I'm still on 1-3, so I'm working right along with you on this one.
Okay. Shelby, are you okay if I just am here?
Yeah, I don't care.
I'll mute myself. Sierra, are you okay if I'm just here and you guys, so you guys just chat with each other, ask each other for help. But if you need me, say Mrs. Main, I'm gonna mute myself and like turn off my screen so you don't see me, because I'll be working on the computer. I'm gonna be like this, and then you're gonna be like, well, that's kind of weird. What is she doing? So anyway, so I'll let you all get to working, and then I'm not gonna record unless there's like good conversation. Like if somebody asks a question, then you'll see me, I'll start recording again. So it'll be a good rich conversation. So because we want to cancel out milliliters, we need to have a milliliters on the top and a milliliters on bottom to cancel, which they did. And then we're left with liters. So I didn't see. Let me go back to that whiteboard and see if it's there, what we wrote on it. So
I just wrote it upside down.
Yeah, so you had it flipped over. Yeah.
Mm-hmm.
So let's clear that just so that doesn't mess with ourselves here. Your thought process was correct. We just had it flipped around. So this is the one that we want. Yep, because we want those to cancel and we want to arrive at that. Well, I'll let you guys go back to you had a good thing going with your whiteboard here.
Okay, number 3, what are the limit for the other calculation? And do they have any meaning?
Oh, what are the units for the other calculation? Do they have any other meaning?
It's on the bottom of page 60. What are the units for the other calculation?
I guess I'm confused at number 3. What are the units for the other calculation? Do they have any meaning?
I think it might be asking like basically why the other one doesn't work, and it would be because it would have a mixed, they would
Oh,
have
because
mixed
of
units at
mixed-
the end.
Okay.
Yeah.
all right, Okay.
So how many liters of magic
Magic
potion?
potion are in the baker. 450 milliliters, right? So how many liters of magic potion are in the?
Mm,
Isn't that the 450,000?
How many liters of magic potion are in the breaker?
Or wait, no.
Yeah, I think it is.
So it wants you to finish what you said you were gonna multiply from number 2.
Mm-hmm.
So you would
So we're left with the 450,000.
get, well, no, because you had 450 over 1,000, right?
Correct.
Oh, divide it.
0.45.
So you would have had 45 over 1,000, right? You have to divide that out. So you would end up, if you multiply this straight across, you would end up with 45, 450 over 1,000 liters. And when you divide that out, that becomes 0.45
Yeah.
liters.
Oh, okay.
So now I want you to practice writing a couple more conversion factors for a different conversion.
Floor handy dandy conversion chart. 1 gallon. 1 gallon.
Okay, so I have them in the two different conversion factors, but I'm stuck on number 6.
Your number stuck on number 6?
Yes,
Did
I
everybody
am.
Did everybody
Me
come up
too.
with their conversion factors?
Yeah, I did.
Okay, so you got conversion factors. So now it says use one of the two conversion factors to convert your answer from question 4. So we want to convert 0.45 liters into gallons. So I always write what I'm starting with. So write what I'm starting with and what I want over here. So we want gallons. So I'm just going to write gallons over here. So the two equivalents that you could have written here, I just want to make sure okay. My two equivalents could have been 1 gallon, right, over 3.79 liters. Or we could have had 3.79 liters over 1 gallon. So we need to multiply, which is going to be over 1. We need to insert one of these choices, either the left or the right, to be
I would
able to. So which one will cancel out liters if we use that one?
I would think it'd be the
left.
one on the left,
Okay.
the
And
one
what
on the left,
about the one on the left, Teresa? What does it?
because you have the 3.79 on the bottom is the denominator, so it'll cross off the liter off 0.5 and the liter off 3.79 and leave you with the gallon.
Okay, so the reason we're choosing number 1 or the one on the left is because the liter will have a liter on a top and a liter on bottom. And so that's why it'll cancel. So we're gonna have 1 gal here and 3.79 liters here. Yes. So those will cancel and those will cancel. Oh, somebody say you're Christopher Frederick. Hello, we're working on lesson 1.4. So we canceled out our liters, so we're done with gallons. So now, once we have our units situated, then we can just multiply straight across, right? And so I'm going to share my, oops, I meant to share my screen so that I could get to my Desmos. Where's my Desmos screen? There it is. Okay. Can everybody see my Desmos screen?
Yes.
Okay. So my Desmos screen I am going to multiply 0.45 divided by 1. So if you hit your backslash for the divided by, it automatically puts it in a fraction, which is nice. And then it tells you where the arrow or the parentheses should go. So I'm going to hit right and then the right parenthesis. And so that filled that in. And then I want to multiply. So I'm going to put another left parenthesis and I want to multiply by 1 divided by 3.79. And again, I'm going to arrow right and put my right parenthesis. And so that the two parentheses next to each other shows multiplication. And so we end up with 0.12 gallons. 0.12 gallons. Is everybody good on that piece?
So it's just, is it just a unsaid thing that we always round?
It depends. If it's money, we round to 2 decimal places. This is gallons, so I just chose to round it to. It didn't tell us an appropriate number to round.
Okay. Because I would have probably not put it on there, but wrong.
Huh?
I said, because I probably wouldn't have, and I would have got it wrong.
So, I mean, we couldn't round to whole gallons because we'd have 0, right? So we had to round to
Correct.
something reasonable, so I chose to round to 0.12.
Okay.
So next up is going to be number 7. So number 7 is essentially saying, instead of doing 2 steps where we did 1 step here going from milliliters to liters, and then the second step where we went from liters to gallons, we really could have written it all in the same step. That's what essentially 7 is asking us to do, is just to write it as one process instead of 2 pieces. So we would actually have 450 milliliters. And then we would use that first conversion. And then we would also have the second conversion at the same time. So there goes our milliliters, there goes our liters, and I'm just circling what I wanted at the end, which was gallons. And then we could add those in. If we wanted to, we could go back and redo that in Desmos, but that should come out to be the 0.12 gallons. Any questions on that one? And then at the beginning of the lesson, don't forget, at the beginning of the lesson, they gave you a whole page that was a bunch of conversions that you could use, right?
Yeah.
So. On page 56.
Inches.
I'll let you all work here. There's a whiteboard back. What did everybody get for number 8?
I'm struggling through it.
I am
I think
too.
you're- I think I understand the concept, but I'm having a hard time getting it in the right order. And
So
whatnot.
what did we start with and what do we want at the end?
So we're in miles and we have 15 miles to start with. So that's where I started on my paper.
Okay, so we could do 15 miles, right? Okay. And what do we
No,
want
and-
at the end?
We're gonna end with inches.
Okay, so I'm just gonna write. Okay, anybody else want to edit? So we need to get rid of miles to get to something towards inches, right?
Yes.
So it's like you're doing the lowest conversion factor.
Okay, so
Right.
what, I don't know miles to inches, so
Right.
I'd have to do something in between there. So is there anything anybody knows that's in between there from our page 56?
Feet are pretty easy to convert to.
Okay, so somebody wants to write a conversion factor, add it to the annotation here and see if it cancels out miles. I'll be right back.
I'm with you, Shelby. I kind of know what I'm supposed to be doing, but I'm missing the in between here.
Okay, there's 5,280 feet per mile. Because if you go back in your book, there's the conversion.
Mhm.
And then,
Okay, in the book where?
On page 56.
yep,
On 50.
3 feet equal 1 yard, and then 12 inches equals 1 foot.
Oh, did not go back that far. I was looking at everywhere else. Okay.
So, yeah, that's what I was thinking.
Okay.
So then we can get rid of miles there. Now that equals, wait, did I do my math right? Yeah,
I got
79,200.
Yeah, you can get rid of the miles and then you're basically timesing 15 times 5280. That should give you 79,200, I think.
Yes, in
Yeah.
feet.
And that would be our feet.
And now we need inches.
Right, so we're gonna kind of do the same thing, but with feet and inches. Times, yep,
Oops.
that's it. Did anyone get an answer for that yet?
I think so.
I have, what, 950,400?
Yes,
That's
that's what
what
I
I got
got as
too.
well.
Okay. And then that is in inches.
Sweet.
That looks good. So what'd you come up with for your total then?
What's that?
What did you all come up with then for your total? Yeah, you all agree that your miles canceled and your feet canceled?
Yes.
Good job. Persistence pays, persistence pays. So when we multiply it all, what did we get?
950,400
950.
inches.
Good job, good job. Now somebody wants to write that, so I'll put it in here. 950, 400.
Yes.
Okay, that way though. Inches. Good job, good job. Okay, so now you are ready to move forward.
Okay. How did we get to the 950,400?
Yeah, there's a missing step on the actual whiteboard up there, but you take the, so let's see, where are we? So then the next step is multiply that 12 over 1 by 1 foot over 12 inches. So then you're left multiplying the 79,200 by the 12.
So you pretty much just multiply them all together.
Mhm. So I'll show you how you can just take these three fractions and put them in Desmos here. So
Okay, I found it.
you found how to do it in Desmos?
No, I just figured this, once she explained the step a little clearer, then I figured out how to do it.
Okay, you got. So I can show still. 5280. Oh geez, what in the heck did I have there?
Oh, I thought the 4 chihuahuas.
I thought I was hitting shift and I was hitting some A0 weird thing. And then the last one would be this. There you go.
Well, I gotta make sure I start using that. That's a lot easier than trying to do it on my.
Yes, Desmos is much easier. It's worth it to struggle a little bit to figure it out, because then it's like you'll be ready to go when we get to unit 2. So, okay, excellent. So that was question 8. So you are all moving on to question 9. More about the love potion.
Convert. You know, if this would have been last year, I probably would have been able to do this because I was in 4th grade working with this. And I was actually understanding it.
I don't think I've ever been good at this.
Well, the teacher there broke it down to 4th grade level.
Sometimes that's what we need.
Now I'm back in 2nd grade, so hey, I was in kindergarten there for a while. I'm like, advance me, get me moving up.
I tell you, I was one of the people that was dreading having to take this.
Oh, take the math class. I hear you.
Yeah, yeah.
I do math every day at my job. And
Oh,
pretty serious math, but it's not structured like this. It's not the same.
where do you work at, Shelby?
I run the Wesco.
Oh yeah,
In
you're the
Brooklyn.
Wesco. Are you
Yeah.
are you in the office running the Wesco?
Yeah,
Wow, you're a big deal.
we do lots of math, that's for sure. Just not this math.
I bet you're doing conversions, you're just not thinking about it like that, so.
Yeah.
Okay,
I That's me, sorry.
I'm gonna clear this so that you guys can work on number 9.
Okay, I gotta get to number 9.
Okay, so now we're going to Deca. Decaliters. Volume, nope, deciliters.
So we. Oh, I like how that's laid out.
Kilo and deci.
He's saying no. Tens, hundreds, thousands.
So that's on page 56, just in case anybody's
We're
wondering.
going from liters
Okay, so
to So we need to move the decimal to the left.
into deciliters and kilo. Shifting the decimal. So we have to go left and right.
Thank you. Deciliter, kiloliter, shifting the decimal. So from the kilo. So a deciliter to a kilo, it looks like it goes to the left.
Is it just one place?
It just says move decimal left. It doesn't say how many.
I think
Okay,
you
so
can
down
talk-
here,
So if you're, you're starting in the middle,
mhm,
the arrow says move decimal right. Like your first
Move it
column
is-
is 1, the second column is 2, the third column is 3.
sweet.
Oh, okay. So from DL all the way to KL is 1, 2 is 3. Correct?
Correct, and that would be
0.23.
to the left, I believe. For the KL.
Right, correct. I'm not say right, I was mixed up. More reasonable measurement. 0.23 liters.
3.
Deciliters. Middle.
So are we moving the decimal and going? I'm just
Oh, we
asking.
should be going to the right one, correct? For the, I don't
For
want
the first one, for
For the-
deciliters, yeah.
Well,
So it should be 2.3 deciliters.
correct.
Yeah, that's what I got.
And then for the kiloliters, I think it should be 0.00023.
There is no point.
Well, you're moving it and you're adding places. So yeah, I
Looks
also.
like that. Yes or no?
No, you're moving it the other way because kiloliters are bigger.
Right, that one we're actually going to the left, so.
All right, Miss Main.
Looks like on here though, from liter to kiloliter, it's to the left. Is that what you
Mhm.
said?
Yeah,
Yeah.
you'd move 3 places to the left for the liters to kiloliters.
Right. So it's-
What's your question?
So you're saying like this?
When you go
Yes.
from liter to kiloliter, you move to the left, but if it's 0.23, it says you go 3 places to the left.
Right,
correct?
Which means, yes, so if we put a decimal place in front of 0.00023, I don't know if can we just, yeah. That would be the correct answer for kiloliters.
Okay,
I guess you'd kind of have to draw it out, so you start out, I don't know exactly how to draw them here, but.
Oh, do you see at the top
if
of your
you-
computer? It says you are viewing
Yeah.
and then view options
View
and click on that.
options,
And then you're gonna look for annotated.
annotate. Now draw.
Yeah.
Oh my gosh.
so who's on here right now? Who's writing? Is this Shelby? Is this you?
Nope, this is Darla.
Oh, Darla, so that's you on here, okay.
So for the second one, we started with 0.23. And we need to move 3 spots to the left. So we're just kind of moving once, twice, 3 times. That's the new spot. We write our empty digits in there and leave our 2, 3. I don't know if that makes sense versus just writing an answer out there.
Did you see why we moved to the left, Darla, instead of to the right?
If you're looking at the chart on page 56, it shows you.
Yeah. I just thought when you went to kilo, the dot wasn't here, the dot was over here in the middle. Because if you draw liters here, this is your dots go here, here, here. Does that make sense or no?
That's only if you're moving to a smaller unit, but kilos are bigger.
Okay,
Yeah.
okay.
You guys got that figured out, agreed upon?
Please, so.
We did-
It's a tricky thing. The whole metric system is a tricky, a tricky thing for me to wrap my head around myself, so,
It's only tricky because we're Americans.
yeah. And when I was in elementary school, they were telling us we were by I don't know, some date, everybody in the world was gonna move to metric, but it never happened. And I was like, oh no, do I move the decimal to the left or to the right? Like, it's very stressful. I'm still like that. Okay. So the good thing is the rest of the lesson is not about moving your decimal left and right. It's about an actual kind of thinking thing. So we can go back to Dr. Phale's love potion on number 10.
So, but for the answer for number 9, it's what is a more reasonable measurement in this case? So when we when we decided we went from the liter all the way down to the, would we go all the way down to the deciliter, to the kiloliter, all the way down. So how do we write that down for our answer then?
So you went, so you were here, right? And then for the
Correct.
deciliters, you said it was 2.3 deciliters, and then kiloliters, you said it was 0.00. You went 3, right?
Yes,
So
3 zeros, yeah.
So which one seems more reasonable? So most of us would feel more confident talking about whole numbers. So I would say the one that has some whole number in it, the 2.3, is probably the one that would feel more reasonable to talk about.
Oh, so that's all they were asking. Okay, see, I guess I'm
But,
trying.
but if you're like, you know what, I don't really grasp what a deciliter is, and that's not something that you'd rather think about that, then maybe you're thinking about, oh, I can visualize like a 2 liter a pop, right? And then half of that would be a liter. And so maybe you could visualize the 0.23 liters more, just because you, like in our brains, we know what a 2 liter looks like. So we can envision what a half of so what a 1 liter would look like. Does that make sense? So
Yeah.
you should pick something that makes sense to you, like what seems the most reasonable to you.
So there's really no wrong answer with that one then?
No, on this one, it's just what seems more reasonable to you.
Oh, okay. See, I guess I make it harder than it is.
Yeah. You got it. Okay, so now we're moving on, oops, to Dr. Phale's potion again. So now they're saying it also comes in a 0.75 gallon container. So we're gonna do some comparing.
And it looks like 1 cubic centimeter is the same as 1 milliliter. Mm.
How's everybody doing with like number 10 and number 11?
I'm still on number 10.
So am I.
And if I'm on the right track, I think we need to take it from gallons to liters and then liters to milliliters.
I would agree with that.
So that's what I'm in the process of doing currently.
Okay, oops, I'm gonna give you back a whiteboard. I'll clear it all out.
Okay, I got an answer, but I have no idea if it's the right one.
I say go for it.
I ended up with 200 milliliters, which should be equal to 200 centimeters or cubic centimeters.
You ended up with what? I didn't hear that.
200 cubic centimeters.
Mine's maybe off a decimal. So can you put on the whiteboard?
I did round it, so it could be up. Oh, off a whole decimal? Never mind. That wouldn't do it. So,
Yeah, if you want to write.
okay, let's see, what do I have? Okay. That's how I got it. Oh, there's a decimal there.
You know what? Go back and look at your conversion for the liters and gallons. I think it's 1 gallon is 3.79 liters.
Oh. So one.
Yeah, yeah, on page 56, down on the bottom there. Volume, it says 3.79 liters equals a gallon.
Oh, okay. So I just wrote it backwards. I see.
Yeah.
This is why you shouldn't have dyslexia, guys.
Okay. It gives you practice.
Here.
So when Shelby flipped that over, did anybody else get theirs finished up?
I did not.
I had 2,842.5 cubic centimeter.
That's what I had as well.
And to do that, the first thing that I did was take the gallon. I just did the gallon to here. Sorry, guys, I keep forgetting and we can
You're right. You got
draw
the,
on there. So basically we just did 1 gallon.
you're gonna show mine if you want to explain. I think you must have gone through the same process. So if you want to explain your process, I think is what I must have done.
Yep. So basically we have I did mine a little bit differently, but it works the same. So the 3.79 liters over 1 gallon times 0.75 gives us, the 1,000 milliliters over 1 liter. And then you're basically timesing, what was it? The 3.79 times 1,000 gives you 3790 times 0.75,
Mhm.
which then obviously gives you the end answer there. But yeah, basically just multiplying those 3 numbers on the top.
Yep, I think Shelby just had hers flipped around and that's all that, it just kind of caused that just to be flipped. So you can write it as CCs or you can write it as cubic centimeter, cm cubed. Mhm.
Okay, I have a question.
Mhm.
Where did you come up? I had the 0.75 and the 3.79. Where is the 1,000 ml from?
So if we use the metric equivalent page
Okay,
right here,
okay. Yep,
these are the base units.
right.
So it goes basically 10, 100, 1,000. So there's 10 of these in here. It's always what it is in the base unit. So the millis are always 1,000s of whatever the base unit is.
Oh, okay.
And so that means there's 1,000 milliliters in 1 liter.
Gotcha. Okay.
And then these are the tenths. the 100ths, and the 1000ths. Only going to the base unit. So everything else you move just like it does this decimal left and right, but these are, if you want to just go from the, to the base unit.
Okay,
For one.
that's what I would, that's the step I was missing. I kept flipping through my sheets looking and I was, okay, thank you.
You're welcome. You're welcome. So number 11 is just asking you to actually cancel out these and verify that you're getting cubic inches. So whenever it says cm cubed, which is what we ended up here with these cc's, is the same as a cubic centimeter. Whenever it says cubed, it means that if you're doing an exchange, you have to exchange 3 of the individual cm's to get cm cubed. So if I want to exchange cubic centimeters into cubic inches, I have to do the exchange 3 times, 1, 2, 3, so that I get inches times inches times inches, which is inches cubed. And then in Desmos, you would just put each of these in a parenthesis to multiply. On that one.
So I got a question for you, Sarah. When you put in decimals, because I don't have it in front of me, would you do the parentheses? The 1,000 and then parentheses 0.254 parentheses 254 parentheses 2.54.
Yeah, let me show, I can share that with you. Yep. So. Yep, you could type it just like they have it here, 1,000. And then the 1 divided by 2.54. And actually, because there's 3 of them, you
Yeah.
could, down here, there's a menu screen for your keyboard. So you can do things on the keyboard. So if you wanted to put that as an exponent of 3, to do it 3 times, you could do this a to the b, and it's gonna go up here and make a 3 there. So that tells you that you're
Oh,
doing
wow, okay.
the 1 over 2.54. The other way to do that is your caret symbol, it's called.
Yes.
And if you do your shift and your 6 key, that's also the caret symbol, and that will also take you to the exponent.
Oh, okay.
So if you're going to repeat that multiplication of 1 over 2.54 3 times, you could just say to the third if you wanted to.
Okay.
Yeah.
It's little tricks of the trade I have to learn.
Yep. Yep. It's just the more you use that good old Desmos.
Okay. 12.
Mhm.
Use idea.
So without Desmos, how do you solve this problem?
Which one?
Without
The
decimal, she said.
Number 11 without Desmos. Like if I don't, I mean, I do have it, but if I didn't have it.
Then you would just. So if you have a regular calculator, is that what you're saying?
Yeah.
Yeah.
So yep, so you're gonna do this, you're just gonna you're gonna multiply that 3 times then.
So
Yep. So, I mean, in your calculator, I mean, you might say 1,000 and then you're essentially dividing by 2.454. And then you're gonna hit divide, so it's another 2.54 in the bottom, and then you're gonna divide and it'll do it again. So you're essentially
Oh, okay.
dividing 1,000 by 2.54 3 times.
So you're dividing that multiple. Yeah, okay, that
Oh,
makes
see,
sense.
I guess I thought in parentheses it was times.
Well, you're multiplying, because this is really,
Oh, okay. I get it.
this is really a divided by 1, right?
Right.
So you're multiplying straight across, so it's 1,000 times 1 times 1 times 1 over 1 times
Oh.
2.54, 2. So it
Gotcha.
essentially becomes this.
Okay.
But it depends on, but because multiplication and division are kind of are in a way interchangeable, you know, in a way, the way you say it. Depending on what calculator you're using, you're kind of saying a different thing. Just like dividing by 2 is the same as multiplying by 1/2, right?
Yes.
So it's the same thing. And dividing by 2.54 is the same as multiplying by 1 over 2.54.
Okay.
So then it says, use the idea from question 11 to convert your answer from question 10 into cubic inches. So your question 10 is the 2842.5 cubic centimeters, right? And we want that to go into cubic inches. So now I'm doing that same thing we just did in Desmos, but I'm starting with this many cubic centimeters instead of just 1,000. So I can show you in my, oops. So in Desmos, it's the same as this. But here I have the fact that I'm starting with 2842.50. Oh, geez.
No, knock it off. No. Honey, it's okay.
Did everybody see how I did that for number 12? So it becomes this right here. The 173.45. And then 13 is saying, based on what you just did, fill in the blank to create a shortcut to convert between cubic centimeters and cubic inches. So we just did the one with 1,000, and then we just did the one right up here with the 2842.5. But essentially, we're just using this right here. So can I annotate right in this? I wish I could annotate on this screen. That would be super awesome. But I can't. So where my mouse is circling, this right here is essentially 1 cubic inch is exchanging for cubic centimeters. So I can go to back to my Desmos and just say, oh. And just delete that 1,000. And there is my exchange. So 1 cubic centimeter is the same as, oops. 1 cubic centimeter is not that. That's 1 divided by that. So it's really 1 cubic centimeter is 2.54 times, oops, times 0.54 times 2.54. It's 16.4. So I want to make sure we get moving because I want to make sure we get to the lesson check for today. The lesson check is number 9 on page 68, so we have a little ways to go. But I think if I keep us moving, we'll be okay. So is everybody ready to move to page 66?
Yes.
Question 1. So a rate is just a ratio, a comparison of 2 quantities, like 75 miles per 1 hour, 10 milligrams per 1 milliliter. Or you might say, oh, it's $15 for 2 tickets to go to the theater, right? To go to the movie. So number 1 is kind of silly because it tells you what it is. Explain what is meant when we say a car is traveling. Well, it means that in 1 hour, I can drive straight, right, for 75 miles. That's basically what that means.
Okay.
So now we're gonna go with this Dr. Phale's love potion from the beginning of the lesson, and we're gonna now look at it in a light of 2 different quantities. So it says the entire 450 milliliters of Dr. Phale's love potion is supposed to be slowly dripped into a mixture over a 5-hour period. Kind of a pain. Love doesn't come easy. Express this quantity as a rate. So we're just gonna write it like we said it. We're gonna drip 450 milliliters over a 5-hour period. That's all that they wanted us to write. And then it says, simplify the rate you wrote into a unit rate. So up above here, it says a unit rate is a special rate where you actually divide it so that you have 1 in the denominator. So a good example is this one right here, the $15 for 2 tickets, right? If you went to the theater and you're like, oh, it's $15 for 2 tickets, and your friend's like, well, what do I owe you? And you're like, oh, if you divide it, 15 divided by 2, that means that 1 ticket was $7.50, right? That's considered a unit rate. So about, I don't know, maybe it's like 10 years ago at Meyer, well, all stores have to do this now. They have to disclose a unit rate on all their items. I don't know if you have to do that at Wesco or not, all your items that you sell your kids and stuff. But you have to have on your little label a unit rate so that people can compare. Basically, because they're saying that citizens aren't smart enough to figure that out on their own, but we are. Okay. So essentially, that's what they want us to do here is they want us to figure out, okay, so if we're gonna drip this 450 milliliters over 5 hours, then what would it be over 1 hour? How much would I have to drip per hour then?
90.
90 milliliters.
Yep, because
Per
we'll
1 hour.
divide that, and that comes out to be 90 milliliters per 1 hour. Good job. So now go ahead and look at number 4. I'll be right back. I'm gonna go put some tea on.
Milliliters. Simplify the rate you wrote in question 2, so that's a unit rate.
So then. Wait. So isn't the 90 milliliters over 1 hour the unit rate because the 1 is the denominator?
I think so.
Is that what the arrow is? And she already told us, and I just wasn't paying attention.
Simplify the rate. Yeah, so I said, I think I looked too hard. You know, I think too hard, some of this stuff.
I think I was also thinking too hard. So the rate was the 450 milliliters over 5 hours, and the unit rate is the 90 milliliters over 1 hour, I think.
I wonder if she wants it written out like mixture dripped 90 milliliters over a 1 hour period.
So what did
As a
you,
rate. Liters per minute.
yeah, so they want you to go from the 90 milliliters per hour into liters per minute. So if you start with the 90 milliliters per hour that we have, right? We have to exchange 2 units. We have to exchange liquid for liquid and then time for time. So one of the exchanges has to be the hours to minutes. Right? And because my hours were on bottom, my hours that I exchange have to be on top.
And that's because of how your answer was with the hour on the bottom and the exchange on the top initially anyway, correct?
Yep. And then my milliliters started on top. So I'm going to have to use milliliters on bottom to cancel those out. And we already know that there's 1,000 milliliters in 1 liter. We just talked about that a minute ago. So, and I always, when I draw mine out, notice I've already scratched out my units. And that's because I always make sure my units work first before I do any of the numbers. Otherwise, then I'm frustrated at myself that I wasted my time. So I make sure that my units I'll cancel. I circle that I wanted liters on top and I wanted minutes on bottom. And then you can just put the numbers into decimals. Is everybody good with that one?
I feel like I missed a piece of work here. So we're doing 90 divided by
1
1,000.
hour.
Okay.
Well, yeah, it ends up being 90 divided by 1,000 divided by 60.
Okay.
Mhm. Are we doing okay? Christopher, Sierra, Darla, you guys are all okay?
Yeah.
Yeah. I'll step out of the room for a minute.
Okay, that's all right. Okay, so. So the last main pieces, we'll get through this, don't worry. The last main pieces are working with some formulas to do some exchanging on converting temperature. So if you went through to Europe and you had to check your temperature over there, right, you would have to use Celsius because we use Fahrenheit here. So Kelvins is another temperature measurement that they use in science. So it says, while in production, the love potion needs to be kept below 400 Kelvin at all times. The thermometer on the most recent batch currently reads 200 degrees Fahrenheit. One of the formulas provided will convert the temperature to degrees Celsius. Which formula would you use and why? So which one of these, number 1 or number 2, will take us from Fahrenheit to Celsius?
The second one.
One on the right, number 2. Celsius equals, so from Fahrenheit to Celsius. Celsius. Well, I would think it's the one on the right. Number
Yeah,
2,
number 2.
because that's the formula for Celsius. I would think.
Which one are we trying to convert to?
We're trying to convert 2 Celsius from Fahrenheit.
She's asking which one is correct to convert from Fahrenheit to Celsius.
Right, so if we have a Fahrenheit temperature, we're gonna be using the one on the left. Because that would be F. And if we have the Celsius temperature, we would use the one on the right. Because we would then have C. I believe is the correct answer.
See, I guess it just depends on which way you're looking at your questions. I'm looking at it the opposite. Thermometer 200 degrees Fahrenheit. Once a formula is defined to convert temperature to degrees Celsius.
But in order to complete the equation, we have to have F, and we don't know what C is.
So which
So
one?
we can,
So I missed that conversation. Which one did you guys decide to use?
we're split. One of us, some of us think it's 1, some of us think it's 2.
So if we know Fahrenheit, we have to manipulate Fahrenheit to get to Celsius, right?
Mhm.
It should be number 2.
Okay.
Okay, so it says, use the appropriate formula to convert 200 Fahrenheit to Celsius. So that means we're going to do this. And the cool thing is we can put that in. This.
Like when the decimals too. Oh my goodness.
So the cool thing in Desmos, if you press this plus button, you can say, I want to make a note, and you can say Fahrenheit to Celsius, if you want to be able to make a note to somebody. In the, I will put a link to this Desmos in our recording in JetNet for tonight. So you can actually put 5 divided by 9. And then parentheses 200 minus 32. And it looks like that is our 93.9. So I can do another note and say 93.3 degrees Celsius. Okay. So then number 7 says, use one of the 2 formulas provided to convert the temperature to Kelvin. So now we're in Celsius and we need to go to Kelvin. So which one of these do we want to choose? Number 1 or number 2? Celsius to Kelvin.
Number 2.
I would say 2.
Number 2. Yep, we want to go from Celsius to Kelvin. Yep, so it says explain why you chose that formula. Will the batch of love potion be ruined? Oh no. So we're going to go back to Desmos here. And I'm basically just going to take my 93.33, right, and add, it says you're just going to take Celsius and add 273.15. So it looks like we get 366.48 kelvins.
Ooh, that's not good.
But will it be okay? Because it says it just can't, it has to be below 400.
Oh, okay.
So it looks like it's safe.
Yep. I was saying, I read it the opposite.
The potion is safe, thank goodness. Okay, number 8. Use the calculator spreadsheet along with an appropriate formula to complete the table. So if we wanted to do a repeat, using a formula to do a repeat is really nice if you're using a spreadsheet. So I'm going to show you how you can do this in Desmos real quick because I really want to get to number 9 so that you have your lesson check. Okay, so I'm going to share with you in your Desmos screen here. So in Desmos, if you go up here to the plus button and click on table, you can put in 0, 10, and if there's a pattern, it starts to know the pattern. And if that's not the pattern of your inputs, you can tell it that too. So I'm just going to go all the way down to 100. And then up here where it says Y1, I just clicked on it and I'm just going to put the expression. So they said they want us to go from Celsius to Fahrenheit. So we're going to go back to the top of our page there on number 5, and we're going to use the one on the left. So I'm just going to show you on my screen here. We're choosing this one now. We're going Celsius to Fahrenheit, right?
Okay.
So this is, I'm just going to write it down here and you all should too, just so you know which one we're using. 9/5 times Celsius plus 32. So in Desmos, you just have to put the expression part on the right. So I'm going to go back to Desmos. So in Desmos, I'm clicking on this Y1 and I'm just putting the expression 9 divided by 5. Wow. Parenthesis times X1, because I wanted to use what's in this row, this column X1, called X1. And then I want to add, no, I want to add 32. And so there are all my values for that table.
So you put 9 divided by 5 in parentheses, and what's after that? X2? Oh, okay. Or is it 32?
32. It's the formula. So go back to what we wrote on our paper. 9/5 Celsius plus 32.
But you have the X1 in there?
Because you have to
so it's
tell it
9.
whatever you called
Okay.
your label. Yep. So
All right.
whatever you called your column. And so
Okay.
I could call my column, if I wanted to, I could call that C. And I
Gotcha,
have to go over here and I can call it C, and it's happy.
gotcha. Okay.
Yep. Everybody have that? And I'm going to put this link in our Lincoln. So the morning class, we got through number 10, but we're only probably going to get through number 9 here, and that's okay. So I'm going to go back to my paper here. And we're going to do one last dimensional analysis here on number 9 on page 68. So it says, according to the online dosage guide for one brand of insulin, the recommended delivery is 0.2 units of insulin per kilogram of weight each day. How many daily units would be indicated for a 178-pound patient? So we know what our patient weighs in pounds. So I'm gonna write that as 178 lb because that's pounds over 1. And we really want units, right? Whatever units are, it's just insulin units. So we want to know units total. Because it says how many daily units. This is what we want to have. Okay. So I'll let you ladies and gentlemen work for this minute. I'll be right back. Get my tea. So what did anybody have any ideas on how to get started here?
We get, I have it kind of scratched out, but I'm not quite figuring that out there, because there's 1 kilogram is 2.2 pounds.
Okay. So what are we gonna do with that?
So you have to do the 178 pounds over 1, and then you put, is it 1 kilogram over 2.2 pounds underneath? Or do I revert, is it,
Well, we want to cancel out the pounds, so the
so you
pounds.
put the 2.2 pounds on the bottom, correct?
Yep, 2.2 pounds on the bottom, and that's 1 kilogram.
1 kilogram, and then after that, I hadn't got to the next one yet.
That's all right. So that gets rid of our pounds.
Correct,
Now we know how much the patient weighs in kilograms, right?
yes.
So then I think you would multiply by 0.2 units over 80.91, I guess, if you round it, kilograms. What did I say? 80.9.
Well, it's 1 kilogram is the same as 0.2 units. Right? So I think we have to multiply the unit, 0.2 units times the 89. Because once we say 178 divided by the 2.2, which is I think where you're getting the 89, Shelby,
Yeah.
that's kilograms, right?
Mm-hmm.
And for every 1 kilogram, you're going to give them 0.2 units. So it should be multiplying. So let's see. So 178 divided by 2.2 times 80.9 times 0.2. So it should have been, I think, 16.18 units.
Oh, see, I got 16.1. I must have done something wrong.
So it should have been 178. You can multiply straight across, so 178 times 0.2 divided by 2.2. Oh, whoops.
Oh, I don't know what I did, but okay, I did it again and it was right, so. I mean, it was with what you have. Okay.
There it was, 16.2. So 16, and it says round to one decimal place. So 16.2 units should be your lesson check. Right? And then if you want to work on number 10 on your own, I'll be recording it. It's a good one. If anybody wants to stay and do it just for fun, you can stay and work on it. It's a trickier one. I'm going to grab my tea. It's finally ready. Sorry, I had a little tobacco with my tea there. Did anybody try number 10? Is anybody trying number 10?
I'm trying to put it through my head and figure it out.
It's pretty tricky. So the dosage of 1700 milligrams of cephodroxil, I don't know what that is to be delivered to a patient in an IV drip over 75 minutes. Okay, it's applied in a solution that contains 1 gram of the drug in 20 cubic centimeters of solution. The pump used to deliver the drug uses units of cc's per hour. So we know that we want to go 1,700 milligrams over 75 minutes, right? And our goal that we want, they said they want it, the pump is delivering in cc's per hour. So hours, 1 hour on bottom, and cc's, which is that cubic centimeter thing that we did earlier. So we have to get milligrams into this cubic centimeter, and then we have to get minutes to hours. The minutes to hours, that one's not a problem. Right, we can do that. So that part we can multiply 60 minutes over 1 hour. That we can do. And then the milligrams, we know that 1 gram is 20 cubic centimeters. So it looks like we have to get milligrams into grams, right? And then we can use this exchange here that they told us that this is how the medicine comes. So how are we going to get milligrams into grams?
Milla is 1,000.
Yep.
1,000 grams. 1 gram of drug in 20. So would it be 20 over?
So,
I'm thinking, I'm trying to figure out what the next one would be.
so we've crossed out the minutes, right? And we've got the hours. So
Right.
we need to get our milligrams into these cubic centimeters.
Mhm.
So once we know that grams go into this medicine by the 20 cubic centimeters, but we need to get our milligrams into grams.
Should we put 1 gram over 1,000 milligrams?
1 gram. So is it, okay, so 1 gram over 1,000 milligrams. Okay, so that gets rid of our milligrams. Okay, we got grams. But we need grams to go to this cubic centimeters. So how are we going to use the last piece to go to?
Gram.
Oh, Christopher's still here too. He's not giving up. I like it. Everybody's sticking by number 10. So how can we use that last little piece?
Gram has to go in CMS.
It has to go where?
Has to convert down to, something's got to convert down to get rid of the gram.
Mm-hmm.
We put 20 centimeters cubed over 1 gram.
Centimeters cubed over 1 gram. So then our grams cancel. We're left with the cubic centimeters. That's what we wanted. So it looks like our units are what we want, right? Cubic centimeters over hours.
Mm-hmm.
Now we just have to multiply straight across on top and straight across on bottom and then one big division. That's one way we can do it. So 1700 times.
To the third. There's 20 centimeters to the third.
That's 20 centimeters cubed.
You're right.
And that's just our unit is cubed. So we don't have to cube the 20. It's saying that's just our unit cube, which is what we wanted, right? We wanted cc's, which is centimeters cubed.
Gotcha.
Yeah, we learned that a couple pages back. So the top multiplies to 2,040,000. And the bottom multiplies to 75,000. So I'm not sure what I got. Yeah, that's what I got before. Did everybody get 27.2? $27.2 cubic centimeters per hour, or it's the same as 27.2 cc's per hour.
That required a lot of brain power.
That did. But you guys should be proud of yourselves. You crushed it.
Okay, so I just have a question. If the CM cube didn't matter, why did they put it in there? To make see if you messed up your calculation?
If what?
When you had the 27.2 CM to the third.
Yeah.
Okay, if it doesn't matter, why is it there through the whole problem? Just to try to see if you calculate it wrong or not?
Well, no, I'm just saying these are the same thing. cc's and cm cubes are the same unit.
Gotcha,
They're
okay,
just written two different. If you go to the hospital, they're going to say cc's,
correct.
but it's one cc is the same as a cm cubed, and that's why I wrote that, just so that we would know. These are the same thing. Because they gave us an exchange with cm cube, but it's the same as
Right.
a cc. So that's why I just wanted to make sure I
Okay.
kind of verified that for myself.
Okay. That probably would have confused me trying to figure it out on my own without you helping walk through it, just because of that conversion change there.
That's a really tricky one. They added that to this course back, and I like it though. It's good to kind of think about those, especially the students that are going to go into respiratory therapy. Our nursing students have to take our stats class, but our
Right.
respiratory health students, which is you, right, Teresa? You're going to, are you doing respiratory health?
No, I am not, no.
Oh,
And
Mm-mm.
is somebody here going through respiratory health? I can't remember. Oh,
me,
You're,
yeah.
Yeah, Sierra.
So you'll
well,
be
thank you.
lots of formulas. Okay, so anybody that hasn't done 1.3, you'll just need to work on that. But that one, like I said, I've already got the videos up in my YouTube videos, so you can check those out if you want to work on that and check your work. And the lesson checks are just due by Sunday night, but tonight you could go in and do tonight's and just get that one done, right? And then do the 1.3 when you get there.
Okay,
Thank you.
thank you.
You're welcome. Have a great weekend, and I'll see you
You
all on
too.
Tuesday.
Bye. Thanks
Bye.
everybody for helping.